Hello, everyone. Welcome to another Bounty episode of the Day Zero podcast. I'm Spectre. With me is Z. In this episode, we have some Cloudflare bugs, a possible XSS and Ruby on Rails, and a 0-day in .cms, as well as some other topics sprinkled in. So, we'll jump right into our first topic here, which is from Asset Note. It was a 3-part blog series on Cloudflare Pages, which covers 4 or 5 different bugs that were discovered and reported. It's got a bit of a story-like style to it. You might be able to tell if you're watching and can see the title. They kind of borrowed the Lord of the Rings titles, which was a bit of a fun part of it. First part's called the Fellowship of the Secret. Second part, the Two Privesques, and finally, Return of the Secrets. Getting into the issues, though, the first blog post that we have up here details the attack surface they were looking at, which were the jobs involved in the Azure pipeline. So they just took a look at what was going on and what kind of build scripts were involved. They noticed that some jobs were provided the GitHub prod private key and Cloudflare prod API token to the environment. So that got them looking at the build steps that were provided those keys, which were the clone repo and publish asset build steps. And these would run through a Python build tool that Cloudflare had. And this is kind of where the bugs come into play when this build script gets invoked. So um, the first issue here that I'm just coming down to is a fairly straightforward command injection. They run a move command on line 74 here, which you can see in this image that they have. They have this move command, and they use root dir for formatting the first parameter of the move. But that root dir parameter can be user controlled, and uh, yeah, there's like no protection against command injection there. There were some hurdles they had to overcome because of some defense and depth that was set up, mainly the fact that the directory had to exist or it would fail, which they were able to get around by just creating a directory with the name of the payload for command injection, which was kind of an easy bypass, but was also kind of neat. Um,
Yeah, I
just
think
taking advantage of the fact that the file system doesn't really like prevent you from using special characters and directory names makes it possible to do that.
yeah, I
Go
think
ahead,
we
Z.
covered another topic. It was a few weeks back, where they had something similar where they had a command injection, but they had to actually have a real directory existing also. And yeah, I mean the file system lets you put in a lot of characters, and a lot of things that are um that you wouldn't necessarily think of as being part of a normal file name, but you put quotes around it, it's like, whatever, okay, it's just a string of bytes. So you're able to create some, so when in that move, they don't end up quoting it at all and just let it out. And obviously no escaping or no attempts to escape it. Pretty trivial command injection there. But I can kind of understand a developer thing like there is a directory, this does exist, therefore it's safe because it represents an actual directory, not realizing just how permissive the directory names and file names can be.
Yeah. The other thing was there was technically some input validation blocking special characters from being entered in the control panel, but that was purely client-sided, so it was fairly easy to get around that. So with the command injection, they were able to cat the environment to a temp file, which could be exfilled through the build logs. They were able to dump the private GitHub key and such, which had a pretty massive impact because the token they ended up leaking here for the clone was a global token. It wasn't scoped to each user. So they ended up getting access, like this token could give access to like all 18,000 Cloudflare page users repositories, which is pretty incredible. It seems a little weird because they had some of that defense and depth set up earlier with like the directory names, but then they seem to have completely botched the scoping on the token. But um, yeah, that's one thing they call out here. And then they get into the second vulnerability, which was another command injection in the publish assets step. Um, Very similar to the first bug. They run a command that they build up using a user controlled asset directory, and there's nothing preventing using characters to break out of the command. Um, Ultimately, with those bugs, they were able to escalate to the AZ DevOps user from the BuildBot user, which effectively gives root because AZ DevOps has a passwordless sudo access. They wanted to see if they could take it further though and break out of the container. So this is where the second blog post comes into play, which is the two privesks. Um, and that one, they found another command injection to add on to the pile that they found from the first post. Um, this one was directly through the build script, through the account and variable directly in the workflow, where it would pass it to the build script. So that gave them another way into the AZ DevOps user and container root access. From there, wanting to see if they could escape the container, they started poking around. They discovered that it was running inside of a Docker container. And they had access to the Docker socket. It was bound to var run docker.socket. And even though technically user namespace remapping was happening here, so root in the container wasn't real root, obviously. Um, but because they were able to talk to Docker, which was running as real root, they were able to take advantage of that to create a privileged container that wasn't confined by any namespaces and mounted the host file system. And yeah, they were able to basically create a container to escape the current container, um, which again they kind of call out as blocking access to the Docker socket for a container you're trying to use in like a security context should be one of the first things you do. But yeah, that
I
that
mean,
didn't end up
ideally,
happening
you
here.
wouldn't even mount it inside of the inside of a untrusted container.
Yeah, you just wouldn't allow them access to the Docker socket. But yeah, in this case, they were able to access that, so it was a fairly easy container escape as far as that goes. The third part is a revisit to Cloudflare pages after a long while when the other issues they reported were fixed. Um, and Cloudflare had sent out a notice about a new pages environment for testing. So this environment that we talked about for the first two parts is completely gone now, basically. So Asset Node took a look. They discovered some of the big changes, including shifting away from using Azure pipelines and instead using Kubernetes through GKE. gvisor was being used for containerization, and build scripts weren't readable anymore. So yeah, very different from the first two posts. Um, a lot stronger security in general. They started doing some initial recon though, just to see if there was maybe something they could find. They did some port scanning and used Kite Runner to enumerate API endpoints, and they discovered the pod's kubelet internal endpoint on port 10255. And when they tried requesting it, they found they were able to do so with like no credentials or anything like that. And they were able to dump some credentials, including the get access token. So yeah, that was their last finding. It was a pretty limited finding compared to the first few because this get access token is actually properly scoped, so it only allows access to your own organization's private repositories and not everybody's. There could still be a bit of a security impact there, where maybe you have some kind of isolation between different members of the organization, and uh, yes, one member can like leak and exfiltrate secrets from another repository that they shouldn't have access to. But yeah, it's way less impactful than the first few issues. But they were able to find something even in this like more hardened and overhauled environment. So that was pretty cool. But
Yeah, I thought it was
overall, just
interesting
an
that
interesting chain of issues.
I thought it was interesting that they actually did after the first couple vulnerabilities actually went through and did a fairly significant overhaul of their architecture for this, going into changing out the basic foundation of it from Azure pipelines into Kubernetes on GK. Just an interesting move, like a positive move. They made a lot of the right decisions there, but also interesting because usually, like a lot of times, you see vulnerabilities get reported as and they patch the immediate issue, and it seems like they tried to tackle a lot more of the foundational issues here, which is absolutely what we want to see when they're trying to patch bugs, but it's not something we often see.
Yeah, for sure.
And for a lot of these bugs, I mean, like I said, they're a lot of them were kind of easier vulnerabilities, but I don't want to downplay the obvious effort that went into actually digging up these issues and going through the code and discovering them in the first place by Asset No. Like, they are easier vulnerabilities, but there's a lot of background, there's a lot of context that you kind of have to wade through in order to get to this point. So, easy vulnerability, but still a good bit of effort went into this.
Yeah. And kind of continuing on the easy vulnerability train, I guess we can get into our next post, which is from NCC Group on a vuln in Ruby on Rails. So, Z, I'll let you take this one away.
Yeah, and this one really surprises me by how simple it was. And I mean, Ruby on Rails is, I mean, maybe it's not the most popular thing to use anymore, but it's got a pretty lengthy history. So the idea that this has been around for so long is a little bit surprising. Anyway, the actual issue here is some cross-site scripting attacks. Um, and there's kind of two groups of them, largely the same sort of issue going on. The first group of them are in the options argument to some of these form tag helper methods like checkbox tag, label tag. Basically, you would like give it the method, what tag name, and you can give it this arbitrary data as an option there. You can give it the just a hash containing like what's going to go into these data attributes or area attributes, or it can just be as the options in general to it. Either way, you give it this hash map, and if a attacker can control the key names being used, it seems like basically the key names were not being escaped at all. So if an attacker could control the key, they would be able to get cross-site scripting directly. It is a little bit of finesse to control the key. Usually attackers have, or in a lot of scenarios, you're going to have more direct access to the actual values being used rather than the keys being used. Uh, but it does happen. Like it's reasonable enough that I could see that happening. So it's a little bit surprising that it's been around so long, or potentially around so long. I didn't actually dig up where this was initially added. And the second one is in the more generic content tag and tag methods of tag helper this time. Um, Basically the tag names also we're not getting. That does feel like a little bit more of an ask for an attacker to have control over those, but not necessarily impossible. I do think the like these data attributes are a bit more likely in my mind. Uh, they don't actually go into what the root cause was, but I did do a little bit of commit surfing on this one to find the patch. And like I kind of guessed, it seems like they literally just were not escaping the keys at all. So very straightforward cross-site scripting. I was just genuinely surprised to see this in some like Ruby on Rails, which has been around for a good while, and you'd expect some of these low hanging fruit to have already been discovered. So, like I said, not sure how long ago this was introduced, if it was maybe reintroduced for some reason, versus having always been there, but it did surprise me.
Yeah, it could just be one of those situations where it's an area that's not really thought about too much and just wasn't looked at. Um, but where, like, in some possible scenarios, an XSS could end up being abused. Because, like you said, like getting control over the tag names and the keys is not a scenario. Like they might not even really be thinking that as an attack vector, even though they should be. Um,
The
but I could
keys
kind
are
of.
they're one of the places I would always look for that when I was doing like web app assessments, because it's something developers do tend to forget about. Like they'll think, oh, I've got to escape this value, but not the key. When an attacker has control, and that does happen somewhat often. I mean, it's not the most common feature to be able to get control there, but it does happen. Something that would always pique my interest.
Yeah, the key is basically trusted, or yeah, treated as like a trusted value when it shouldn't be.
Well, and who, like, offhand, I mean, do you know how the key needs to be encoded versus how a value would be encoded? In value, you've got kind of the quotes there, the key, well, what's the encoding for that? What should you be doing? Um, I can understand developers just not thinking about it as much too. It is something I like. That particular aspect is something I've seen. Not so much with the actual tag names. I can't think of a lot of cases where attackers have that level of control, but no, like I said, it's straightforward. It just seems like it's uh not being sanitized here at all or escaped at all. And yeah, I mean, I really don't have much more to say on that.
Yeah. All right, so we'll get into our next topic here, which is also from Asset Note. and it was on an arbitrary file upload vuln in .cms, which affected an undisclosed bank which used it. .cms is a Java-based CMS, and this is another one of those posts where the vulnerability was relatively simple, but exploitation of it was a bit more interesting because of some of the hurdles they had to overcome there. So boiling it down to the vulnerability, it basically is a directory traversal in the process file method through the multi-part put and post endpoints, which were unprivileged. Here they would take some user data, write it to a user-controlled file name in the temp directory, but it would just build up that path with string concatenation, and so arbitrary files could be uploaded because, yeah, there was just nothing preventing traversing out of that temp directory.
Yeah, on the
Um,
unprivileged note, I will say that it's by default unprivileged. It did depend on the configuration. So it could be configured in a way to not be insecure. There's the content API allow anonymous configuration option, which could be set to write, which would allow anonymous users to write. So that was the default case. Um, I don't know why that should be the default. Because yeah, I mean it's literally a file upload. Like generally, you don't want anonymous users uploading files. So having that as the default is also surprising. But there
Insecure defaults
was,
for the win.
yeah, but there was technically authentication that could exist there. It's just not the default case.
Yeah, good shout. Um, but yeah, so because by default it was, accessible to anonymous users, and the fact that directory traversal was possible, there was the arbitrary file upload vuln. In a regular .cms setup, this is pretty easy to take to code execution. You just upload a web shell basically. When they tried to do this on the bank, though, it was a little bit tougher. And that was just because of some hardening that was in place. Notably, the fact that they try to prevent being able to write into the root HTML directory to be able to get an easy web shell. Now, obviously, when you have arbitrary file upload load like this, it's pretty. There's a lot of different ways you can go. Like, you don't have to use a web shell. That's just usually the path of least resistance. Um, but the approach they went with here was a bit more interesting. While they weren't able to replace the HTML files or like upload a shell, they were able to replace the JavaScript files that were being served, like in the assets directory. So that's kind of the path they pocked, just showing like attacking the bank's customers or whatever, serving
So
some malicious code that might do something interesting. I believe that's the route they went. They're not like totally clear on
it's a little more
that route.
complicated.
Okay, so
They
I'll let you
actually
get into
did
that then.
something interesting here. What they did was they went after the e-tag. So if you're not familiar with e-tag, basically server can provide or as I understand it, I'll be honest, I didn't go dig into it. It's been a while since I've looked this. But effectively, server, when it sends you something, it can provide you an e-tag value, and that's going to be the next time you make a request, it's like has content change sort of request to see if they need to see if the client needs to update their cache. They can send this e-tag value, and the server will kind of know what was being requested and possibly serve that file back based off of the cache entry. So effectively, as I remember it, e-tags being used kind of like a cache entry. Um, so what they did is while they couldn't write into where the actual JavaScript file was, um, they could control the e-tag file. So they could write to that folder, which I believe this is set at the Tomcat level. I don't think it's specific to, because usually this is going to be implemented at the server level rather than the application layer.
Yeah, so it's not being set by .cms.
Yeah, so basically the first character, second character, they basically just found out what the file format was to access the e-tag, wrote the asset for the e-tag itself rather than overwriting the original file, and that's how they were able to get control over the JavaScript. I will apologize right now if I get some of my understanding over how the e-tag is kind of processed there, but I did think it was interesting that they used that rather than being able to actually target the original path of the JavaScript file. But I might be missing some details. And they did have another little trick here that I want to shout out, because we mentioned this on some other case where one thing you have to do when you have this sort of issue, you want to overwrite a file, you need to know where you exist or where where what you want to overwrite exists on the target application or on the server. And those paths, like, yeah, under Docker containers and stuff, like, you'll sometimes see some very similar paths, but they could technically be anywhere. And the way they got around that was using the proc self current working directory folder. So as their directory traversal, they just back all the way out with a bunch of dot slashes, and then go forward into proc self cwd, which would get them into the directory of the script actually doing the uploading, like that execution, rather than had they just done like the dot slash, they'd be relative to this temporary directory that it was trying to place them inside of, which was elsewhere. Which is just a worthwhile trick to at least be aware of here for getting to a bit more of a stable location when it comes to these sorts of attacks. So I thought it was worth calling that out along with this E-tag attack, which I haven't seen the E-tag thing before, so I'm not sure how applicable that's going to be across other servers. But it definitely kind of piques my interest a little bit to dig into and see how applicable that would be to, say, like Nginx or something. As a target for overriding, that is.
It's kind of interesting because that proc self CWD trick, like in hindsight, it looks like a very obvious way to go and it's very useful. But I haven't really seen it used in a lot of the blog posts we cover that deal with directory traversal. So yeah, I don't think I've seen that trick covered on any of the other topics. Maybe I'm just misremembering, but
No, honestly,
yeah.
the most of the time when I've seen that used, it's actually been CTF write-ups rather than actual uh real world vulnerability write-ups.
Yeah. So good trick to be aware of. Um, yeah, thanks for clearing that up a little bit with the e tags because it was a little bit confusing to me because I was like, okay, they can't upload to the like touch the HTML files and upload a web shell, but I was thinking maybe the asset directory where the JavaScript files were was maybe not protected properly. But yeah, that makes more sense with the e tags. I guess I just kind of skipped over that when I was reading it. So yeah, good shout on that one. All right, so we'll get into a crypto issue that we have up next, which was a price oracle manipulation vuln in AV3, which is a liquidity protocol that deals with things like flash loans and such, lending and borrowing, DeFi type stuff. Um, as far as crypto issues go, this is probably one of the simplest ones that we've covered, probably. But even so, the impact here is pretty massive because you're talking about the potential of over 2.9 billion in funds that could have been drained according to this blog post. So, yeah. So first, they talk a little bit about price oracles, and for those that aren't really familiar with like what price oracles are or like why you would need them, um, where some smart contracts are dealing with lending and borrowing, a contract needs to be able to look up a like price or exchange rate. And this is a very tricky issue because the idea with smart contracts is that everything is decentralized. And as such, what sounds like a simple task is made much more complicated because what do you rely on as a trusted oracle? You have to rely on an oracle or multiple oracles that are trusted and can't be influenced by attackers. And that's kind of a tricky issue.
Well, and you
And then
can't do
even,
things like read out to the internet. Like, you can't just use some random API on the internet. Everything on the blockchain's on the blockchain.
yeah,
That's all you
yeah,
can
that as well.
communicate with.
And then even if you use a trusted oracle that's used by many other smart contracts, you run the risk of having like a single point of failure type deal where if that oracle is compromised or goes down, your contract can be vulnerable to that. Um, furthermore, there could be a case where you're using a trustworthy oracle in an incorrect way, which is kind of what's happening here. So here, by default, in normal situations, they use the Chainlink oracle, which is a popular choice and it's a well tested oracle. The problem is in their get asset price function, they kind of have this fallback case where if the Chainlink oracle returns a zero, so basically it can't get a price, it'll call into this other fallback contract that they have, which, as we'll get into later, is not production ready. But yeah, I'll talk about that when we get to it. Um, and that fallback contract has absolutely no verification or access control on the method for setting the asset price. So you can kind of see like this is the contract here, very simple contract. Yeah, just like no checks at all, really. So any attacker could just call the set asset price method on the fallback Oracle contract and yeah, manipulate the price. Now, actually exploiting this would be a bit tricky because you would need to force that fallback to occur and thus get Chainlink to return zero, which is kind of an unlikely case. But because of some other issues, it becomes a little bit more practical. So they detail two scenarios where this could be possible. One of them is the fact that Aave used a deprecated function from Chainlink. They use latest answer instead of latest round data. And the problem there is it's possible for latest answer to return zero if no answer could be reached. That's kind of shouted out in the documentation as that actually the reason why it was deprecated. And the other scenario that could lead to the fallback contract being used is if an asset is added as collateral before the price feed of that asset is configured. So, like a brief window would open up where the fallback oracle would get used. Though they didn't end up finding a standard procedure in the documentation for adding a new asset, but that's a route that they call out that could be a potential attack vector. But
Yeah, both of these are like they do feel fairly unlikely to happen. They do depend on constraints outside of an attacker's control. An attacker, unless they're part of like the agreement nodes or like the agents that Chainlink is using, they're not going to be able to like cause this no answer to come up. I mean, maybe some denial of service somewhere, like they might be able to do some weird attack there. But effectively they're dependent on those agents failing to come to an agreement on what the price is and thus not having an answer or some other thing happening. Uh they just have to wait for that case to happen. Or as the secondary case that you were just mentioning, the second place where fallback oracles used is when the asset they're trying to access hasn't yet been set. Just or the sorry, the source for the pricing of that asset hasn't yet been set. Um, that one, like, I don't know because I feel like you should be able to do that all in one transaction. So I can't imagine a really good reason why you'd actually end up like they speculate that this could be done, but they don't have any information on how that's actually updated, and neither do we. It just feels like that should be a single transaction. It's not like the web where you can kind of race it, and even that you'd have to know when it's happening to race it, which would be something an insider is doing to add the new assets. Again, you're kind of just waiting for the right scenario. So maybe a malicious miner or something could be watching for just the right transaction that opens it up and insert their transaction at the right time. But other than that, like, it does feel fairly difficult, and they're just kind of waiting for all the stars to align basically in order to actually exploit this. Um, that said, the fact that that fallback oracle has like comes out of the mock contract. I can't remember if you mentioned that or not. It's something that shouldn't have been deployed to production. It was in like the mock folders, so developers were using this just to test things on like a mock chain. And thus it also didn't get audited because it's not supposed to hit production. And yet here it is in production because somebody decided to deploy it. Um, yeah, just crazy simple vulnerability, but that's what seems to happen in so many of these crypto cases. It's just not thinking, not realizing the implications of what they're doing, whatever, leading to very or potentially significant vulnerabilities. Like had this been used anywhere else, so would have mattered quite a bit more.
yeah, and I mean, even though the attack doesn't seem super practical, or like you kind of have this high condition to exploit it, there is a massive incentive to do so, even with that stipulation. So uh,
Yeah,
shouldn't
they're
be
just
discounted.
waiting for the right conditions to happen. That's all I'm saying, not that nobody would be waiting for it. Like if
Yeah,
those conditions happened, reasonable chance somebody was already waiting for it.
yeah. Smart contracts are a little interesting in the way that it seems extremely difficult to write them correctly. There's just so many things that you have to be aware of when you're writing them, and as your applications or deployments get more complex, um, it seems kind of easy to miss these things. Although yeah, deploying a debug or development contract like this is pretty bad. Um, they call this out a little bit towards their conclusion on the auditing aspect, because they said like this protocol was audited by a good chunk of the major firms that do contract auditing, and they were just calling out like this is a good example of why more auditing needs to be done on the actual deployment, as opposed to just the contracts that are being like written and developed. Like you need both, obviously, but a lot of the focus in smart contract auditing has been on like um, the typical contracts you're going to put into production, which makes sense. But the deployment issues aren't really focused on as much. So yeah, they're kind of using this as a bit of a PSA to, you know, auditing companies, but also to companies that are purchasing audits to put some thought into making sure that things like this, where test code doesn't end up in production, that's pretty important
Yeah,
too.
and
So
that matters quite a bit more here in crypto versus just like your standard kind of web application or something, where you can have a like you can fix the web application a lot easier than you can fix a crypto thing. Where crypto, once it's on the blockchain, it's there. Um, like there are some sort of update mechanisms you can implement and stuff, but it's not as easy to do an update to fix these things. That said, on the since you mentioned the audit companies, um, I feel like this is something that some of them probably do try and sell their clients, but the clients are like, no, no, just look at our code. We'll deploy it properly, and not wanting to pay extra to have a more in depth or like I get in a sense like a full integration test would effectively what comes down to. Making sure their actual deployments are correct and all of that would be kind of an extra stage of an audit and cost more. I could understand companies being like, no, we're getting our contract code and then assuming all the rest is right, which they shouldn't be, but I have to imagine that places like Trail of Bits are offering that and places like this are just rejecting that offer rather than it being the case that the auditors just aren't aware of that. I've definitely written a ton of reports where I've talked about like, yeah, I mean, like we did this test of this in test environment, but I suspect this thing might happen in production. So like, could we have a test of this environment or whatever? Like I've had to write a lot of those. I have to imagine it's the same for those doing the crypto assessments.
yeah, and like you said, I could kind of see places doing that where they shouldn't be, but it's easy to have the hubris to think that like deployment is easy compared to development, but often it can lead to just as many pitfalls. So
Yeah, and I mean it's one of those things where auditing the code is really what matters. The code needs to be right, but you can have these other issues come up, and it is a bit of a different workflow for doing that sort of audit. So it would be like a separate engagement, a separate project to audit the deployment versus the actual code itself. You're looking for completely different types of issues in that case. Just different things to be aware of. So it could even be different people doing it. Um, it, it's just another step in that maturity process. I'd start off by getting that code audited, and then as company matures, they go on to have more complete testing.
all right, so we'll get into our last topic here, which is a HackerOne report for Reddit, and I'll let Z take this one away.
And this is just kind of a fun little bug. It's over in ads.reddit.com. Oh, pretty straightforward. They've got the repro steps here or the actual issue itself is just the ability to bypass email verification and set your email to whatever you want. And it comes down to once you create your account, usually you have the normal verification process. Skip that and just go right to the account ID inventory type page here. Actually seems like it's a page where you can change account settings because where it ends up making an API request to is it makes this patch API v2 accounts account ID. So just making this generic patch request to the accounts endpoint ultimately. So if you change the data on that, or not even change it. You can change any field you want, but if you just add the email field into there, um, this patch request will go ahead and update your email, and presumably that email field is the verified email, so you're setting that to whatever you want. You can pretend to be any user you want because you can directly modify it. This kind of comes down to, I've seen this sort of issue before where, they'll write this generic handler for just this patch request comes in. Okay, what fields are there? Just take the field and set it. Take the field and set it, and just doing that. And then somebody passes in a field that they're not expecting you to be able to set. They don't have any UI for it. Or presumably they don't have any UI for it, but it doesn't care about that. It just checks if the field exists, most likely, and sets it. Um, Creating this bypass of actually verifying the emails. So, fun bug. Common enough situation when you have these very generic endpoints. Ideally, you should be whitelisting the actual fields that you'll update or having other conditionals set on there, but oftentimes people forget to do that, so this slips through. Pretty straightforward issue though, and kind of a fun one. I do like seeing these things. It kind of reminds me of old, like, what was old PHP used to do. I want to say it was called like magic variables, but I think there was another name for it where you could set local variables using just like your query parameters. So you can overwrite variables that didn't expect you to be able to overwrite, basically. Um, I butchered the explanation of how that one worked. It's not an issue anymore. It hasn't been a thing since like PHP 3, but it kind of gives me that sort of vibe, at least.
Yeah, cool issue, and pretty good bounty as well. I mean, resulted in a $5,000 bounty, so pretty cool for the researcher there too. Brutamol
Uh,
asks in chat, do they check if the versus the email if you're part of an organization?
they don't call it
Um,
out as to what checks actually happen here. And it seems like to me the likely case here is that this email field is what would be, well, so as part of the organization, it might be used at some point. To answer your question, I guess no, I don't know. Um, this just seems like being able to directly modify this email field that would normally only be set once you're verified. So I could imagine certain areas actually checking it. They do mention that you'll be able to accept invites sent to an email if they had an invite to an ads team at that email that they hadn't yet accepted. So there is definitely some checking going on based off of that email, but not clear about the organization aspect.
yeah. All right. So unless you have any last minute notes, see, I guess we'll go ahead and wrap up the show because that's all the topics we have.
Nope, no shout outs.
All right. So, like I said, that's all we have for today. Thank you everyone for joining us. Check out our website or chat for Twitter and Discord links. You can also find summaries and VODs up for our previous episodes on our website and our YouTube. Other than that, though, we'll be back tomorrow for binary topics. That's at 7 p.m. Eastern, 4 p.m. Pacific, and we'll see you then.